Hello everyone, and welcome to today's lesson on transform fault boundaries. Today, we'll be exploring the fascinating world of plate tectonics and learning all about how these unique geological features shape our planet. So sit back, relax, and let's dive into the world of transform faults. The objective of our lesson for today is to explain the different processes that occur along the plate boundaries. To begin, answer the activity 1. Change the number with corresponding letter in the alphabet to determine the word /s. The answer is earthquake. The answer is fault line. The answer is pass each other. The answer is plates. The answer is grinding. For activity 2. Listen to the knock-knock in the video clip. Take note the important details about transform fault boundary. Afterwards you will make your own knock-knock.
Hey Ryan, want to have a little fun with knock-knock jokes but with a geology twist?
Sounds intriguing. Let's give it a shot. You start.
Knock-knock.
Who's there?
Transform fault boundary.
Transform fault boundary who?
Transform fault boundary, just like our relationship, shifting and sliding, causing seismic changes between us.
Chuckles, that's clever. Okay, my turn. Knock knock.
Who's there?
Fault.
Fault who?
Fault. Just like a transform boundary, our connections' movements are unpredictable and full of twists.
Nice one, Ryan. All right, my turn again. Knock-knock.
Who's there?
Plate tectonics.
Plate tectonics who?
Plate tectonics, just like a transform boundary, our love's movements create friction, shaping our journey with unexpected turns.
Geology puns never get old, Emily. Thanks for the laughs.
Anytime, Ryan. Now let's get back to studying these fascinating plate boundaries.
Did you enjoy the clip? Are you ready to make your own knock-knock? But before that, what is transform fault boundary? A transform fault is a type of boundary where two tectonic plates slide past each other horizontally. These boundaries are characterized by intense seismic activity as the plates grind against each other, causing earthquakes. The movement along transform faults is typically lateral, meaning the plates move horizontally in opposite directions or alongside each other. The transform faults can occur in both oceanic and continental crust. Transform faults are often found along mid-ocean ridges where two tectonic plates are moving apart, as represented in the illustration. Remember that the presence of a ridge is an indication of diverging plates, and as the plates diverge between two segments of the mid-ocean ridge, the adjacent slabs of crust are grinding past each other. Although most of transform fault are located with the ocean basins, there are a few that cut through the continental crust. Transform faults occur within continental crust is a result of the lateral movement of continental plates past each other. Unlike divergent and convergent boundaries, transform boundaries do not typically produce volcanic activity because they do not involve the creation or destruction of crustal material. Imagine your palms representing tectonic plates at a transform boundary. The surfaces of these plates are rough and uneven, much like your skin. As you rub your palms together, the irregularities create friction. Similarly, at transform plate boundaries, the rough surfaces of the plates generate friction as they slide horizontally past each other. This friction builds up over time, causing the plates to resist each other's movement. The accumulated stress and strain lead to the storage of elastic energy within the Earth's crust. When this stored energy is suddenly released, it triggers an earthquake along the transform fault boundary. This release of energy is analogous to the sudden slip or slide you might feel when the friction between your palms is overcome. Therefore, just as friction between your hands can lead to movement and energy release, friction between tectonic plates at transform boundaries causes earthquakes due to the sudden release of accumulated stress. The most famous example of this is the transform fault associated with the San Andreas Fault System in California, which is located predominantly in the oceanic crust of the Pacific Plate. This fault boundary separates the Pacific Plate from the North American Plate. Now let us check your understanding. Answer the questions briefly. Question number 1. What causes the friction between tectonic plates at transform boundaries? Answer. Friction between tectonic plates at transform boundaries is caused by the rough surfaces of the plates rubbing against each other as they slide past horizontally. Question number 2. Why are transform faults characterized by intense seismic activity? Answer. Transform faults are characterized by intense seismic activity because the plates grind against each other, causing earthquakes due to the accumulated stress and strain. Question number 3. How do tectonic plates move along transform faults? Answer. Tectonic plates move laterally or horizontally in opposite directions or alongside each other at transform faults. It's knock-knock time. For the knock-knock activity, create at least 2 knock-knock inspired by our discussion about transform fault boundaries. You can write them in English or Tagalog. For the activity 5. My plate boundary. Create a model of a plate boundary using available materials. Example: paper, cardboard, clay, markers, paint, recycled materials. Be creative and use your imagination to represent the Earth's crust and the movement of tectonic plates. Use these scoring rubrics as your guide. Have fun and explore different ways to represent plate boundaries and geological features using the materials you have. Remember, mountains and volcanoes are not typically formed directly by transform plate boundaries. Transform plate boundaries are characterized by horizontal sliding motion between tectonic plates, which usually results in shearing and faulting rather than the uplift associated with mountain building or the volcanic activity associated with volcanic arcs. As we end our journey through the realm of transform fault boundaries, I extend my gratitude for joining us in today's lesson. Thank you for exploring the dynamic world of plate tectonics with me. Thank you.